Good evening, dear students. This side Dr. Manushi Mukhopadhyay. Today again we have met to discuss on certain issues of periodic properties, certain issues on periodic properties of the elements of the atoms. Last day we discussed about ionization energy, and today we are supposed to discuss about electron affinity. Now, what is electron affinity? To understand that, first we have to remind once more ionization energy. Ionization energy is the amount of energy required to release one electron from the outermost orbit of an isolated gaseous atom. So it is the amount of energy absorbed and the electron at the outermost orbit is released. Electron affinity is exactly the opposite, the reverse concept of ionization energy. Electron affinity is defined as the amount of energy released to take one electron in the outermost orbit of an isolated gaseous atom. Formally defining, electron affinity is the energy change that occurs at an atom when gains electron. Now, what is the trend of electron affinity? Same like ionization energy. It increases in the periodic table from left to right and it increases from bottom to top. So if we go on like this, we will be having a trend like this. If this is the periodic table, it will increase from bottom to top in the periodic table and from left to right. Now, next comes to be physically defining electron affinity. Electron affinity reflects the ability of an atom to accept an electron. It is the ability, it is the mode of acceptance of an atom to accept electron in the outermost orbit of the valence shell. It is the energy change that occurs when an electron is added to the gaseous atom. And naturally, atoms with stronger effective nuclear charge have greater electron affinity. More the charge, the positive charge at the center, more it will be attracting the outermost electron to be added to the outermost orbit. And the reaction that occurs when an atom takes an electron may be represented like this. X is an isolated gaseous atom. It takes up an electron represented by E minus. So X, as it accepts, we are giving it a plus sign. X plus E minus, that leads to X minus. Now X is having more electrons, so the charge is negative. Plus energy, that means energy is released. Plus energy is in the right hand side of the arrow. That means energy is released. So the formal representation of ionization energy is X, which is an isolated gaseous atom, plus E minus leading to X minus plus releasing energy. Another way to define electron affinity is the amount of energy needed to remove the electron from a singly charged negative ion. That is what I said. This is actually the definition of ionization energy. So ionization energy and electron affinity are exactly opposite. So they only differ in the sign. Ionization energy is represented as plus sign as energy is accepted, or in the left hand side of the equation, and electron affinity is represented as release of energy, that is negative energy, or in the right hand side of the arrow. Now moving on to the next slide, the sign convention of electron affinity. Electron affinity is most often represented in terms of kilojoule per mole, or kilocalorie per mole can also be the mode of representation. Sometimes the values given in terms of magnitudes are relative to each other. In the value of electron affinity, or EA, electron affinity is represented as EA is negative. If the value is negative, it means energy is required to attach the atom, as I said earlier, and negative values are seen for the nitrogen atom and also for most of the capture of the second electrons. It can also be represented as plus, that means plus energy, that means electron will be released from the outermost orbit of the valence shell. Now the trend of electron affinity, as I said, electron affinity is one of the trends that can be predicted using the organization of elements in the periodic table. These are all periodic properties that I started the class with saying. We will be discussing about the periodic properties, and electron affinity is one of the periodic properties of the elements present in periodic table. So it must have a trend, and the trend is like this, increasing from bottom to top and from left to right. Electron affinity increases from left to right. Now the question is why? Why electron affinity increases from left to right? Before going into that, we must say that the exception is in the case of noble gas. Electron affinity increases from left to right, but we know noble gases are at the extreme right of the periodic table. Even then, they have electron affinity approaching zero. Because the reason being, as we consider they are the noble gases, they have completely filled up octet. They have most stable electronic configuration. They have completed the octet rule and they have the most stable configuration. And electron will only be accepted or released when the configuration is not stable. Maybe they are lacking one electron in the outermost orbit, so that they will be accepting electron, or maybe having excess electron, or maybe having at least one or two electron in the outermost orbit, that they will be releasing electron. In both the cases, if the orbital configuration is incomplete, then comes the question of electron affinity or ionization energy. So we can understand electron affinity for noble gases is approaching zero, although they are placed at the extreme right in the periodic table, and according to the trend they should have the highest electron affinity, but they are approaching zero because of their stable configuration. And electron affinity also increases from bottom to top. Let us discuss what are the reasons for the variation of this electron affinity. The reason of the electron affinity being increasing from bottom to top or from left to right, let us explain. So how it can be done? Let us explain that. Probably I missed one slide. Anyways, let us explain, let us understand. Moving from left to right, what happens? In each case, one electron is added up in the same outermost orbital. That means one electron is increasing in the same outermost orbit and one proton is being added in the nucleus. Now, we know protons, although protons and electrons are of equal charge, but they differ in their sign, they oppose their sign. But then also protons are more effective in attracting in terms of attraction. So, as the number of electron increases, the number of proton also increases in the nucleus, and protons being more effective in attraction, they will be dragging the outermost electron more efficiently as the number of electron increases in the particular valence shell. So, the size of the atom rather is getting reduced, and as the size of the atom is getting reduced, the outermost electrons are coming more closer to the nucleus, and the attraction is more strong. So, they will not either be easily removed from the outermost orbit or they will be accepted in the outermost orbit. This is one reason why the electron affinity or the ionization energy increases from left to right in the periodic table. Next question is why the electron affinity increases from bottom to top. Very well asked question. Let us understand why it is increasing. Now, as we go down in the periodic table, it keeps on increasing its outermost orbital shell. For example, earlier there were one next to what we represent by NPK, and that's it. So, as the number of shell increases, there is a term called shielding effect. Shielding means covering. So, as the outermost orbital number increases, the outermost electron every time is getting blanketed by the addition of this outermost orbital. This is called shielding. They will be covered up, and as there will be shielding, the attraction of the nucleus, that is the positive charges, will be lesser. The control of the positive charges over the electron that is present in the outermost orbit will be decreasing because of the shielding, that is because of the addition of more number of orbital shells. So as the number of shell increases while we move from top to bottom in the periodic table, the attraction between the positive nucleus and the outermost electron decreases due to shielding. That is why while we go down from top to bottom in a periodic table, the ionization energy or the electron affinity decreases, but the reverse happens when we move from bottom to top. Now let us understand what are the factors that influence the ionization energy. Just a second. Yes, the factors on which the ionization energy depends. Number one, as I said, the size of the atom is very important. As the size of the atom decreases, the ability of the positively charged nucleus has more control on the outermost orbital electron. So size of the atom is important. Number two is the nuclear charge. More the nuclear charge, more is the attraction to the outermost orbital electron, and more tightly it will be held and more difficult it would be to release it or to accept one electron in the outermost orbit. Third one is the effective nuclear charge. What does it mean by saying effective nuclear charge? Effective nuclear charge is represented by Z effective. Z effective. Z subscription EFF. And the calculation is somewhat like this. Z effective is equal to the actual nuclear charge, Z actual minus S, that is shielding. So effective nuclear charge is the nuclear charge that we have, the resultant nuclear charge that we have after considering the shielding. As the effective nuclear charge increases, the outermost electrons are more strongly held towards this atom, more strongly held by the nucleus, the positively charged nucleus. Then comes orbital configuration. As I said, if the orbital configuration is a stable one, like the noble gases, it will have lesser electron affinity or ionization energy, because they will be neither ready to move to leave one electron nor ready to accept one electron from the outside. And the last one, but of course not the least, is the filling up of orbital. It is very important. And we know if the orbital electrons are partially filled up with opposite rotation, or if it is completely filled up, either half filled or completely filled, it will have more stable filling configuration. If it is partially filled up and that partial filling is half filled, then also it is stable. But if it is erratically partially filled, it will have unstable electronic configuration, and in that case, it will be greedy enough to accept one electron from the one electron outside to the outermost orbit, or leave or release one electron from the outermost orbital configuration to the atmosphere. And that is all about this electron affinity. So what are the, one thing I forgot, that is non-metals typically have higher electron affinity values than metals. Chlorine strongly attracts electron. Mercury is the element with the atom having most weakly attracting electrons. Now if we go on considering the trend of the variation of electron affinity in the periodic table, we can finally conclude that chlorine is the most, having highest electron affinity, and mercury is having the lowest electron affinity. Chlorine is having the highest electron affinity, or we can say fluorine is having the highest electron affinity and mercury is having the lowest electron affinity. And then what we can say, the examples of electron affinity calculation. The electron affinity of hydrogen is represented by delta H in the reaction. Hydrogen in gaseous form takes up one electron, that is E minus, forms H minus, and the amount of energy that is involved in this case is minus 73 kilojoule per mole. It is the amount of energy required, that is minus 73 kilojoule per mole. So the electron affinity of hydrogen is plus 73 kilojoule plus more. The plus sign isn't cited because ECA is simply written as 73 kilojoule per mole. Now, what are the key takeaway notes from this electron affinity, whatsoever we have discussed? Electron affinity is the amount of energy required to detach one electron from a negatively charged ion or an isolated gaseous atom. Number 2, it is indicated using the symbol EA and is expressed in terms of kilojoule per mole, that is the unit of electron affinity. And finally, electron affinity follows a trend on periodic table, that is, it increases from left to right and increases from bottom to top. And the reason we explained in detail. And that is all I had to say about the electron affinity. Thank you so much.